Assalamu alaikum and welcome. Today I am excited to present an innovative project that combines hardware and software to create an automated entry-exit system. This system leverages an ESP32 microcontroller, infrared sensors, a servo motor, and OLED display, and also a buzzer to monitor the flow of people entering and exiting a designated area. This project is designed to automate door control, keeping track of who enters and exits while providing real-time updates and alerts. As we walk through this project, I will break down each component, its role in the system, and the corresponding code that brings everything together. Whether you are an enthusiast or a student in mechatronics or electronics, this project demonstrates how to seamlessly integrate various components to solve real-world problems. Let's dive into the
Hello everyone. Now I'll explain you how this program basically works in order for our project to successfully implement its function. So we'll start off by including several libraries to handle hardware components. As you can see over here, we're including four libraries. One is y.h and followed by some other libraries, including ESP32 Servo. So the first library is used for I2C communications with the OLED display that we have on our breadboard, and the other two libraries are used for controlling the OLED screen. And the last library is obviously to control the servo motor that is responsible for opening and the closing of the gate. Next up, what we did is we defined our pins upon which we have attached uh, our different sensors and the buzzer and the servo. And afterwards, what we'll do is that we'll initialize the OLED display by defining its width, height, and the function responsible to take in input and display a certain output later on the function, and then a function to initialize servo. Now we'll be defining the variables and the cooldown timer, which we have set to 3 seconds. And moving on to the setup of the function. Um, Basically, at first, what we are doing is that serial communication is started for debugging. We set the sensor pins as input and the buzzer pin as output. We also attach the servo motor to GPIO32 and initially position the door as closed using servo.write 0, the function. And then the OLED display is initialized, and if it fails to initialize, the system halts. After successful initialization, the message system initialized is displayed on the OLED for 2 seconds. And now we will be moving towards the main loop and the events handling. Now the loop function, which is constantly checking the sensor states. At first we use millis to track the current time and the cooldown period, ensuring that the system doesn't react too quickly to repeated sensor triggers. If the entry sensor is triggered, indicating by a low signal over here, the system handles the entry event, and similarly for the exit sensor. Each event resets the cooldown timer to prevent a false trigger. Now the function to handle entry is responsible for handling anyone who enters the gate, and therefore the gate will respond to the input given to it by the infrared sensor by basically opening. Now what happens is that during the initial stage for entry, the door opens and the system waits for the person to pass the exit sensor, then closes the door. The entry counter is then updated and the buzzer sounds in order to show that the person has actually passed and will be later on leaving on the exit sensor, which will then again end up closing the door, and the count is registered on the OLED display as person entered and then person leaving, resulting in a complete count. Now we'll be looking at the door control functions. First up, we have a function for open door in which a servo will write an analog value of 90, upon which it will move to a 90-degree in a state that opens the door. Therefore, it moves upward, allowing the person to pass through. And then another function for closed door, which is linked to the second sensor when the first person has passed to the first infrared sensor, which results in opening the servo motor by 90 degrees. When the person has passed and the infrared sensor on the exit reads a person leaving, it helps the servo motor to reach back to its original state, which is at 0 degrees. Now we're coming to the function that updates our OLED display. Basically, these set of functions right here, they're responsible for updating values on the OLED display whenever a sensor reads a certain value and performs a certain function. Also, servo is included in this case. Now, all of these functions are called over here, but their values, these functions are defined over here basically, and their values are called on over here, over here. In the function that they're given input parameters to perform certain functions to display whatever data we want on the screen. Now, the current counts of the people entered and the people left are provided through these functions, and they are displayed on the OLED. Now we're coming towards the last function, which is the buzzer. Now, basically, what this does is that whenever the entry infrared sensor reads a value one, basically a value on which someone is entering, and at that state, the servo then rotates to 90 degree, opens the door, opens the gate, and the buzzer sounds for 200 milliseconds as the delay is set over here. And then when a person has passed through the first infrared sensor and approaches the second infrared sensor, the buzzer just turns off, where the value is set to low.
And the final conclusion about this project, actually the project works by utilizing three IR sensors to detect and count objects passing through a door. When an object approaches the door, the entry sensors trigger the opening of the door via the servo motor. The exit sensor counts the object as it passes through, which acts as a brain of a system handling the logic for sensors, the servo motor, and communication with the display. It has flexibility, allows us to easily manage multiple components efficiently. Now afterwards we will move up to infrared sensors, which are used for entry and exits of peoples or ships. The TCRT 5000 infrared sensors detects when someone enters or exits the area. These sensors trigger the door control based on movement, ensuring smooth operation. Afterwards, we will move to servo motors, which actually controls the door. The servo motor controls the door and opening when someone enters or exit and closing after they passes. Its precision allows us to automate the door movement seamlessly. Now we will move up to OLED display. The OLED display provides real-time feedback showing the number of people who have entered and exited the area. It also keeps track of the flow in an easy to read format. This is OLED display. So the final component used in the project is buzzer, which is integrated with two IR sensors. Actually, this buzzer alerts us with a sound whenever someone enters or exits. This audible cue adds a layer of interactivity to the system, ensuring we are aware of every event. Now I will tell you about the working of the project. Actually, this project works by utilizing three sensors to detect and count objects passing through a motor. So here is the buzzer to provide audible feedback and an OLED display to show the real-time count of the people or objects entering or leaving. And the ESP32 microcontroller processes all these inputs, ensuring smooth operations and automations of the day. Hope you like this project. Thank you.